Welcome to Maths for E channel. A past question on graph sketching from Oxford and Cambridge past paper. Sketch the graph of y equal 3 to the power x. Give the coordinates of any intercepts. The curve y equal fx is the reflection of the curve y equal 3 to the power x in the line y equal x. Find fx. Let's start with the graph. Y equal 3 to the power x is an exponential graph we expect. Prior to do that, just to get some values to sketch a graph. X equals 0, y equal 3 to the power 0, that is equal 1. Then y equals 0 is not the right approach because of x to the power value is x to the power, 3 to the power value never be 0. It will tend to 0 but never be 0, so it's why it can't be 0 equal 0. Y, say just get some y, x tends to positive infinity. If that's so, 3 to the power positive infinity is positive infinity, so y tends to positive infinity. X tends to minus infinity, then y tends to positive 0 because of x tends to minus infinity means y equal 3 to the power minus infinity, that is equal 1 over 3 to the power infinity, that is equal positive 0. That is positive 0. Because we always have to get positive and negative the values for the graph. So x tends to minus infinity, y tends to positive 0. So this is how it is, right? Okay, the graph is an exponential graph. We know about it, and it intersects y x 0, it intersects the y-axis 0, 1, and the when x tends to minus infinity, y tends to positive, just about the x-axis, positive 0. That's the graph. Sketch intercept is 0, 1, y-axis intercept. The next part, the curve y equal fx is the reflection of y equal to the y equal 3 to the power x in the line y equal x. So don't look at the red curve yet. So just let me go through this. Reflection on y equal x is mean. It's xy swap, it's purely inverse transformation. So just swap x equal y, y equals, say for example, if a point has a coordinate, say p, has a coordinate of a, b, and if it's reflection of this point on x equal y or y equal x will be, say, q, that will be b, a. So simply x become y become x. So that is exactly what it is. So every x values become y values, y become x values. So the original graph is y equal 3 to the power x. So reflection on x equal y equal x is simply swap the xy. So x equal 3 to the power y. From that y, we want to get the y, don't be to get the graph. So y equal log 3 base x. So that is what we have. That is what we have to prove, right? They didn't ask us to sketch a graph, but we can do it. So instead of the way we did it here, just check the x values and then find the y values. Here, opposite. So use the x value. So when y equal 0, x equal 3 to the power 0, that's 1. Then y equal positive 0, x equal positive 0, and y equal minus infinity, y tends to positive infinity, x tends to positive infinity, y tends to minus infinity, and then as I explained to you here, it's 3 to the power minus infinity, 1 over 3 to the power infinity, which will be positive 0. So the graph, now we look at the graph, so if you look at the point A, that was the original curve, the point on original curve, and reflection of the point, it's the B. So it just x y become x. So 1, 0. 1, 0 means it's cross the x-axis there. And then again, if it's when x tends to minus infinity, is positive y. And here it's a straight opposite. So just when y tends to infinity, x is positive infinity, the positive 0. So that's what this one is. So the graph is drawn, even though they haven't asked us to do it, just to give you some explanation or clarity. So y equal log 3 to the power x. That's what we have to ask. That is y equal fx, that is log 3 base x. That's about it. Find fx. Thank you. Please subscribe the channel to help other students, because the more you subscribe, it will reach more people. I just purely want other people to sort of benefit from these contents. Please share the contents with your friends and other A-level students. Thank you.